Alright guys, so what you want to do is first, again, you want to cut this out because when you're taking notes, you don't want your notes to go off of the page. So take a moment, cut that out before we get going. Guys are finished, it should look like this, so take a moment to fold it in if you need to. Alright, so this next topic is called the sums and the differences of cubes, as you can see. This is the case when you have a perfect, not a square, but a perfect cubed in the front and a perfect cube as your second term. The first and the second term. Now, remember when we talked about the perfect squares that you had to have a minus in the middle? Here, perfect sums and differences of cubes, you can do either one. And that's why it's called the sum, because remember, sum means adding or plus, and the difference, which means negative or minus. Okay, so as long as you have perfect cubes in the front, or there's the first term and the last term, no, sorry, I finished that, perfect cubes, then you're good to go and you can use this method. So just to review, going back here on page 37, differences of squares, again, this is where we have a minus in the middle with two perfect squares. Okay, that was the other one, and this one is two perfect cubes. So for example, a perfect cube might be something like 64. Okay, I do the cube root of 64, 4 times 4 times 4, so that one's 4. Or the cube root of, let's say, 8, 2 times 2 times 2, so the answer is 2. Those are perfect cubes. Alright, so open up to the left side. Okay, so the first thing is we need to look at both terms and see, are they perfect cubes? Okay, so I'm looking at the number in front of this x is 1. Okay, so if I take the square root, the cube root of 1x cubed, okay, well that's 1x times 1x times 1x gives me 1x cubed. So the cube root is 1x. And that we call a. So we do that first. Then I look at this number, the cube root of 8. Well, that is equal to 2. And that we will call our b. Okay, then we're going to use this formula up here above in order to write out our factors. And we basically use this formula for every time. So if you notice it says plus b, so because we have plus, we're going to follow this method. So if it's plus here, that means your first factor will be plus. So this first one is always the same. If this is plus, that's plus. Okay, but then the second one, the sign will be the opposite of that, minus. So the first one is the same, but the second sign is always different. Okay, so now we're going to work this out. So the first thing is we have a plus b. So our a is 1x, or just x. Then plus, the same plus our b, which is 2. Times, it says a squared, so basically x squared. Okay, then minus, follow again the same pattern. Then a times b, so x times 2, which is 2x. Okay, then the sign in the back, this sign never changes, and it will always be positive. Always positive. Okay, so plus 4. Okay, then you end up with these as your factors. Now you can kind of look at this second, the second factor, which is the x squared minus 2x, and see if you can factor that. But you notice is that most of the time this will not factor. So if I put the 4 on the top, minus 2 on the bottom, what two numbers multiply to 4, but then add up to 2? Well, 2 and 2 doesn't work. 4 and 1 doesn't work. Okay, so you'll notice that doesn't factor out, so you just leave it like this. Okay, so now what we want to do, that was the one with the sum of the cubes. Now we're going to go over to the other side and do the difference of cubes, where this is the case where we have minus between the two cubes. So now on the right, again, you're going to do that first step is to check, are these perfect cubes? Well, if I do the cube root of 27x cubed. Okay, and then remember this is going to be our a. Cube root of 27, 3 times 3 times 3, so 3. Then x times x times x, so just x. And then the second one, the cube root of 64, well, I showed you guys that on the front. So 4 times 4 times 4 is 64, so 4. Okay, now the steps of this pretty much very similar. You're going to have a binomial and then a trinomial. So now the difference here is, remember I told you the first sign is always the same. So if that's minus here, then that's minus here. Those will always be the same. Okay, so then I'll have minus here. Okay, but then the second sign here is always different. So if that's minus, this is plus. It's always the opposite. So again, this is different. Okay, so I'll have plus here. And remember I told you the last one is always positive. Okay, so we're going to have plus here. Okay, so then here you're going to bring down that 3x. Okay, and then minus 4. And then the first one again is a squared. So 3x squared is 9x squared. Okay, the next one is a times b. So 3x times 4, which would be 12x. And then the last one is b squared, which is going to be 4 squared. So 16. So again, you can try to see if you can factor that. Okay, and for some of you guys, you'll notice that that's a perfect square and that's a perfect square, so you might try that. But remember, you have to check it first. So if I take the square of that, or the square root of that, and then the square root of that, okay, put those together. Oops, sorry, multiply them together is what I mean. And multiply that times 2, does that give me the middle number? Well, 2 times 3 is 6 times 4, 24x. So no, that would not work. So I couldn't do that. So pretty much even if you try to work it out, again, you can't factor it out. You use the quadratic formula, but then what's the point of that? Because then you end up with some decimal type answer or simplified radical, and we don't want that. Okay, that's it. We'll finish the rest in class.